Hey everyone, welcome back to Pine Hollow out of Diagnostics. Today we have a 2008 Lexus IS250, 241,000 miles, and customer complaint is the persistent ABS and traction lights. They said the code is a C1249 hard fault. It's just there all the time. So here it is on the scanner. It says open circuit and stop light switch. And if you try to clear it, it comes right back. It's a hard fault, so the car is broken right now. Let's do some research on this code and see if we can track down the problem. Alright, let's look up some information on AllData. C1249 says when ignition terminal voltage is battery voltage, an open circuit of the stoplight switch continues for half a second or more. Or when the brake pedal load sensing switch is on, the master cylinder pressure is, when you're pressing the brake pedal and there's apparently a pressure switch, the stoplight switch is off for 2 seconds or more. So the second scenario here, I think we can use scan data to see perhaps this master cylinder pressure and the stoplight switch data. See if that's causing the problem, or when the stoplight switch is off, then this first scenario would apply. And the trouble areas are either stop switch fuse, stoplight switch circuit, stoplight control relay circuit, brake actuator assembly, the actual ABS module. Alright, so here's some live data. We have brake pedal load sensing switch and stoplight switch. So let's depress the brake pedal. They both say on at the same time. They both say off at the same time. So that's not going to be our issue. And the other clue is the code came right back after clearing it without even touching the brake pedal. So this is a brake pedal, off circuit check of some sort. We have to look up wiring diagrams and see what the ABS module is fussing about. Alright, so here's a diagram of the fancy layout. So there's a stoplight switch. Apparently it's fed from battery stop switch fuse. Now 1 is automatic, 2 is manual, so just follow the automatic. So apparently there's a stoplight control, looks like a relay, only equipped on the automatic. Then the stoplight switch, when it closes, you should see voltage on STP2 and going through the stoplight control relay on STP1. There's an open circuit detection thing right here. So STP1 and STP2, we have to check both of these because on scan data it just says stoplight switch. So maybe if this relay, if the contact is bad, the switch is still good. We see on live data that changes, but this thing might be doing a circuit integrity check through this stoplight control relay. Now what is this for? That is for the ECU here, the ABS module. You can actually turn on the brake lights without you stepping on the brake pedal. So when this is energized or grounded, this relay clicks on and then you get power, boom, right to A, and A goes to all of the brake lights. Okay? So this circuit integrity check, what could it be? I think we have to find this stoplight control relay and see if there's voltage. Well, it's doing a circuit integrity check with the switch off, with this stoplight switch off, so it must be checking the circuit through this stoplight control relay. Or it's looking for a voltage on STP0, basically seeing if the control side of the relay is fine too. So if we can find the stoplight control relay, we'll be in really good shape. We'll be able to see voltages in all these pins, and it seems like that's the only thing that could be triggering this code when the stoplight switch is not depressed. Follow my logic. So I found a removal stoplight control relay. There are over 50 steps. You have to tear the entire dashboard apart. Instrument panel, knee airbag, blah 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 blah. And it's hiding somewhere way under the dash. This little thing right here. Stoplight control. It's a 5-pin relay, looks like. So I'm wondering if we can get to the actual ABS module, maybe do a circuit integrity check from STP2 to STP1, and then with the key on we should have voltage on STP0. If we ground that, the brakelets should come on. So maybe the easiest place to get to this thing is at the ABS module. Let's take a look. Alright, well this makes me happy. ABS module is right here. Let's unplug this thing, find those wires, and should be able to do our checks right from here. Alright, well on the OE diagrams there are two relays. There's brake lamp relay and stop lamp control relay. So go figure that one out. So how can the ABS module turn on the brake lights? Well, if it energizes the stop lamp relay, this will flip to here, which is powered up, and then send power to the brake lights, because the brake lights right here, automatic, come from the brake lamp relay on pin 3. So when this switch closes, boom, you get brake lights. On the scanner there's bidirectional control, and if I hit the bidirectional control, the brake light does come on, and then they turn off. So that relay seems to work, but in our trouble code description, now guys, the glare is ridiculous. I am in the field outside in the parking lot, so please forgive me. I will try to show the important things clearly. This saying stoplight control relay. It's checking the stoplight control relay, not the brake lamp relay. Okay, so this picture, stoplight control, is that the brake lamp relay? It certainly looks like it, but right here we have two relays. There's stop lamp control relay and the brake lamp relay. So I'm a little confused at the moment. So my question is, let's say the circuit integrity check is checking this from STP2 through the stop lamp control relay to STP1, right? This is what I'm guessing, STP2 to STP1. What if we just jump these two wires with a test light, a little test light, to simulate a relay right at the ABS module? So pins 21 to 27 is going to be a red and black to a red and white wire, and pins 21 and 27 are going to be somewhere in that middle row. Alright, so the red and white, the red and black wires, I just jumped through a baby test light. Clear fault memory. Okay. Read fault code. It's still there. Clear DTCs. Yes. Still there. Open circuit and stoplight switch. Let's do the bidirectional control one more time. Stoplight relay. Yes. On. It works. So are the brake lights going to stay on indefinitely now? And off. So if I unhook this, the brake light's turned off. Let's try that one more time. On. Off. I tie these together. On. The brake lights will stay on indefinitely. So that doesn't work and we still have a code, but we're just trying to learn the system. One more circuit integrity check I want to do, now this is for the brake lamp relay, is pin 16, the STP0 wire. So that should be 12 volts unless the ECU decides to turn on this brake lamp relay. Let's put a meter on. Alright, so the blue wire, pin 16, I got that probed. We're at battery voltage, so when I do the bidirectional test and latch that relay, I expect this to go to 0. Yep, perfect. And off. So that works perfectly fine. Alright, next check I want to do is put the meter on STP2 and press the brake pedal. That should be hot when the brake pedal is pressed and the brake lights are on. So here we go. And brake pedal depressed. Yep, we get battery voltage. So that's good. Finally, on the STP1 circuit, we have 5 volts with the brake pedal released, and then when I press it, it goes to battery voltage. Now, is that correct? Should that be 5 volts, or is that looking for a path to ground? Is that the circuit integrity check? I'm not sure. Alright, so the only helpful diagram here is this OE diagram that has both the stop lamp control relay and the brake lamp relay. So, the one we were bidirectionally controlling is the brake lamp relay. That's the one under the hood, easy to get to. This is the one where you have to take the entire dashboard apart, which is honestly truly ridiculous. This is only for the automatic. So, with our voltage measurements at the ABS unit, we see 5 volts at STP1 when the brake pedal is not pushed. And this is the model without Vehicle Dynamics Integrated Management. That's the really fancy one. So we're number 2. So the voltage comes out right here. And where does it go? Well, it can go towards the stop lamps. These are all LED controlled units. And it can go back through the relay to this stop lamp control relay, which is buried. So my question is that 5 volts normal or is it not normal? Then, how do the brake lights normally work? So stop lamp switch closes, comes here. On STP2 we see a voltage, 12 volts, and STP1 goes from 12 volts, or from 5 to 12 volts. So that must mean when you press the brake pedal, we get voltage at the stop lamp control relay, and somehow it's making it to STP1. How is that possible? Where it has to go through the brake lamp relay from this E2C pin on this buried mystery relay, okay? And this relay has 4 wires, you know, ground, battery power, then the control from the stop lamp switch, and it looks like an output. So my question is, are we calling this relay, or are we calling the ECU, you know, the ABS module? Where's that 5 volts coming from? It has to be coming from the module, because the relay can't put out 5 volts. And is it looking for a path to ground? Like, what is the circuit integrity check? It's slightly confusing, but I'm hoping we can make a definitive call just by looking at this diagram and doing some more voltage measurements. Guys, I was a little confused. If you look at the wiring colors or the labels, this is the one that's automatic only. This is the main stop lamp control relay that's buried, and that works because you push the brake pedal, stop lamp switch closes, energizes this relay, and it sends power on this leg right here, and it makes it through the relay under the hood for the automatic 5-pin, and the brake lights turn on this leg. So everything seems to work just fine. Now what about STP1 sending out the 5-volt check? Well, it would go here, 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 towards the brake lights, and then back towards this stop lamp control relay. So in our troubleshooting tree, what could cause this problem? Stop light control relay AT. So it's not happy about this one, even though this is called the stop lamp control relay. The labels here are, or the names of the relays are super confusing, because this one is equipped on all cars. That's the main stop lamp control relay, and this brake lamp relay is the one that can be turned on by the ECU on an automatic only, and that works. We checked it bidirectionally, it clicks, and also the brake lights work through this leg, so this relay is fine, and this relay is also fine. So why is it setting a hard fault? That's my question. That voltage on STP1, that must be the sensing, circuit integrity check voltage, and maybe 5 volts is normal, because through the LEDs maybe it drops to, it drops to 5 volts through all this stuff. We could unplug a connector. I don't want to cut the wire here, STP1, just to see what the voltage coming out is when it's not going to any circuit. So it's looking like a faulty ABS module. So in the flow chart, I went through the entire list here. They check everything. So this stoplight control relay, that's the 5-pin under the hood. We can check that. We know it works. Measure the resistance between 3 and 4. 3 and 4. That's just straight through to the brake lights. We can jump 3 and 4 just to give it 0 resistance. Maybe it's checking this little contact right here. Alright, so here I have the brake lamp relay from the underhood fuse box, and it sits like this. So we have 2 big pins here and then 3 little pins, and 1 through 5 I determined which one's which. So 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. So pins 3 and 4 on the diagram should be connected, and STP1 is sending a voltage, and I guess checking it through here to somewhere, because this would be an open circuit when you're not pressing the brake. So this circuit check is going on when you're not pressing the brake pedal. So that's what's confusing. That 5 volts comes out, and you wouldn't expect a drop unless it's looking for a drop through the brake lights. Right? But anyways, the flow chart says check the resistance between 3 and 4. Well, I'm checking the resistance between 3 and 4. So So the little copper colored one and the, those two pins, and we have 0.0 whatever 2 ohms. That's fine. It's continuous. That's the way it's supposed to be. That's the default state. So this relay is perfectly fine. Alright, there's another interesting check. The relay's fine. So check harness and connector, stoplight switch, engine room to relay block. There's a stoplight switch. There's the relay under the hood. It says measure resistance. A22-1 stoplight control relay terminal 4. So from here to here, below 1 ohms. On the diagram, that would be from here to here, below 1 ohms. But how do we get from here to there? We have to go through this junction connector to STP1. Well, that doesn't make sense. Or through the stop lamp control relay from here to here, to terminal 4. So you have to go through this. We can try that resistance check, but it doesn't make any sense on the diagram. Harness or connector. Well, let's try it since they're telling us to do that check. Alright, so we're doing a resistance check from this red and black wire on the stoplight connector to pin 4 at this relay. We have infinity. Let me just make sure my ohm meter works. So that'd be 0. There's no continuity. Is that why the code is setting? That's pretty crazy. Why should there be continuity there? So the crappy thing about this flowchart is they're going by this diagram, which doesn't include the actual main stoplight relay. It just includes this one for the automatic. So it says we should have a wire, one automatic from pin 4 the relay to the stoplight switch output. So they're checking this continuity, but in reality this is the real circuit. So how are you supposed to get continuity from here through the stop lamp control relay to pin 4 of the relay? Well, obviously this is open when you're not pressing the brake pedal, so there would be no continuity. Well, we have a hard fault. We checked all the wires and the relays, and guess what? Replace brake actuator assembly if the DTC is a hard fault. So that's going to be my final call, unfortunately. So it's up, the customer's probably not going to invest in that. But that's the end of the diagnosis. So thanks a lot for watching, and we'll see you in the next one. Bye-bye.